Hello everybody and welcome back to the Big Questions Made Little. This video I'm going to be talking all about the down, bottom and strange quarks. So let's get into it. First off I'm going to start with the down quark. Now last time I spent a lot of time talking about the up quark, the charm quark and the top quark. This time I'm going to be talking all about the quarks that are often paired with them. I'll come to that a bit more later, but I'm going to start with the down quark, which is paired with the up quark. Just over half the mass of your body is made up of down quarks, because every single part is made up of atoms, and the mass from atoms comes from the protons and neutrons in the center. Most atoms have slightly more neutrons than they do protons, and because neutrons contain 2 down quarks and 1 up quark, and protons contain 1 down quark and 2 up quarks, you're slightly more down quarks than you are up quarks. So most of the mass in your body comes from these down quarks. They have a charge of -1/3, and they're usually very stable, which is why they make up neutrons and protons and how so much of your mass can come from them. However, if they're forced to, they can decay into an up quark, electron, and an electron antineutrino. And some of those particles I'll come back to later. But what I mean when I say decay doesn't mean it just randomly falls apart into them. Everything in the universe tends towards a state of entropy, which means it's the state that's got the least energy, that can change as little else as it can. Because of this, there's a theory that one day the universe will just become a massive soup of energy, just photons flying out away from each other for eternity as the universe expands faster than the speed of light. Because at this point, nothing will be able to break down into anything else. There'll be nothing smaller for matter and energy to break into. How this ties into the down quark, however, means that if it has to, it will split apart, if you like, or break up into an up quark, an electron, and an electron antineutrino. This will produce energy. But it's usually very stable, which means it's already at so little change is left that can happen to it that it usually won't change. Next I'm going to start talking about the bottom quark. This, like all fermions, has a 1/2 spin. Fermion essentially means it's a matter particle, because some of the elementary particles are energy particles, and they're called bosons, and they have a spin of 1, or an integer spin, and I'll talk about those in a later video. And the bottom quark, again, it does decay into something. It decays into a charm quark or an up quark. The last quark left in this video is going to be a strange quark. I've spoken very briefly about the other 2 quarks so far, but I'm going to talk more about them all as a whole. Now, a strange quark will decay into an up quark if it's not stable. Also, these particles all have a 1/2 spin and a charge of -1/3. But I'm going to talk more about quarks as a whole at the minute, because this is my last quarks video. The matter particles, if you like, the fermions, are split up into 3 different groups. First generation, second generation, and third generation, right? And each of these 3 generations contains 2 subtypes, a quark and a lepton. Quarks are solid matter particles. They're affected by gravity, the strong nuclear force, the weak nuclear force, and electromagnetism, which are all 4 of the fundamental forces. That's why matter reacts to all of these things, because that's what matter, atoms, are made up of. Then you've got the slightly more fuzzier, if you like, particles, leptons. They are technically matter particles because they're fermions. They have a 1/2 integer spin, but sometimes they behave like waves. The most famous example of these is something called the double slit experiment. This is something I'm going to talk much more about next time, when I'm talking all about electrons, muons, and the tau particle. Anyway, the first generation quarks are the up and the down quark. That's why they're always paired together. They're the most common quarks in the universe. They're what make up protons and neutrons and therefore atoms. Also in the first generation is the electron and the electron neutrino. You'll have of course all heard of the electron because I've said it about 5 times in this video, and they're also in atoms. The second generation contains the charm and the strange quark. Again, I've spoken about those over these last 2 videos, and the muon and the muon neutrino, but I'm going to talk more about those in the next 2 videos. And the third generation are the top and the bottom quarks, and the tau and tau neutrino. Notice that if you look at the quarks, the mass of them increases dramatically each time. If you remember, I said last time that the up and down quark have a mass of 1/3, whereas the top and bottom quark have a massive amount of mass. That mass is equivalent to 1 technetium atom, which is considerably larger. It's tens of hundreds of thousands, therefore, of times more massive than just 1 up or down quark. And the charmed quark and the strange quark are also far heavier than the up and down quark, but they're not as heavy as the top or bottom quark. Now, these particles are all very important because they are physical matter particles. They're proper, solid, physical particles. It's difficult to describe things like this because they're not made up of anything. They're not, when you talk about an atom, you can describe how the protons and the neutrons and the electrons react around each other, and when you're describing what a proton or a neutron is, you can say about how the up and the down quarks inside are arranged and ordered, but there's nothing inside one of these particles. They're pure, or if you like, they're utterly solid, but even that's not really the right term to be using because that refers to an arrangement of atoms in a physical object, like a phone. They're all solids. It's very difficult to describe any of these particles, but these quarks are very important because they're what give you your mass, if you like. They are what makes you up. Your physical body is made up almost entirely of up and down quarks. There are lots and lots of electrons in there too, don't get me wrong, there are lots of electrons, but nowhere near as many. In fact, there are roughly an equal number of up and down quarks, usually a good deal more down quarks, but it's roughly the same. But the number of electrons is, on average, between 1/3 and 1/2 of the number of up quarks. And the electrons are what allow atoms to react with one another. They're what allow you to function on the inside. Every single chemical reaction going on inside of you, every thought you have, every time you move something, even the reactions just keeping you alive, producing energy inside of you, or breaking down foods, or building up proteins, is all to do with the electrons switching atoms. But none of this could happen if it wasn't built on the foundations, if you like, of the up and down quark. If you think of an atom as like being a house, then you could say that the electrons are almost like the bricks. But the up and down quarks are the mortar, the cement, and the concrete foundations. They're the supports, if you like, the thing that give your atoms, that give matter a structure. This video went possibly more philosophical or metaphorical than they tend to on this channel, but I'm not going to apologise for that because I think I tend to teach a bit better when I'm being philosophical. This was quite a short video today. It's only going to be about 5-10 minutes long, but thank you for watching, everybody, and I'll hope to see you next week. Please don't forget to like, comment and subscribe, and I'll see you next time. In the meantime, have a good week.